we go to the two well-known applications. The first is the ping, and another is the trace route. Okay, the ping just use the echo request and echo reply, and then in the router, of course, in your Windows or in your Linux, you can use ping as the command line interface. And then ping, you can forward directly by a IP address. Yeah, IP address or host name. And then if you specify ping 10.0.0.2, okay, this is the address of router B. Then the router A will sending a ICMP echo request to this address. Then when the router B received, then will reply with an echo reply. Then RTA will receive it, then know the RTB is there. This IP address is alive in the network. Okay, this is the ping. And when you're using the ping, you can specify some options. Okay, for example, you can ping, then specify the -A. Then this A is to select the source IP address. You can use a different source IP address. By default, which IP address will be used? The IP address configured on the outgoing interface. Okay, if the router sending this ping, this echo request from this interface, then the source address is using this interface. Okay, if there's other interface and connect to other routers, then if ping this address, then source address will be using this. If you want to change the default behavior of the router, you can specify -A, then the IP address, the source IP address. Of course, the source IP address must exist in the source router, and then followed by the destination IP address. Okay, this is the option -A, and then option -C. C means what? The count. Specify the number of echo requests. When you're using ping to the destination, then not only one packet, not only one echo request is sending out to this interface. There's a sequence of echo requests. How many? 5. The default is 5. But you can specify the number. For example, you only want sending 2 echo requests, then specify -C and then followed by 2 and then destination IP address. Okay, this is the -C option. And of course, there's others, -N, -T. And the -N means numeric output only. No attempt will be made to look up host address for symbolic names. That means not use the domain name. Okay, domain name. And -T to specify the time to wait. When the packet echo request is sending out, then the destination will reply. The reply, you should wait some times. Then how long will we wait? The default is 2 seconds. Okay, 2000 milliseconds, just 2 seconds. Okay, wait 2 seconds. Okay, this is some options. Of course, different systems have different options. You can use ping and to check if there's any other options. Okay, and then this example. For example, you just using the default method ping, and then this is the destination IP address. Of course, when this ping, the source address of this echo request message is the output interface of this packet. Okay, then the echo request will send into the destination of this address, and will repeat 5 times, and then you can get the information how the size of the echo request, and then the sequence, and then the TTL. Remember the TTL just exists in the IP packet header, and the time to leave. Okay, then the time. This time is when the source sending and then reply. Okay, the time when sending and reply. This is the time period. Okay, time. Okay, this is the ping. And another well-known application is a trace route. Trace route just to check the path selected from the source to the destination. Okay, maybe in the network there's many different routes. Then you can choose which route is chosen by the packet from the source to the destination. Okay, you can use trace route. Then trace route, then followed by the destination IP address. Then the path, each router, each packet will, each step, each hop will be listed here. Okay. Of course, the trace route also have different options. The A means to set the source IP address, to choose the source IP address. If you not specify this A, then the output interface address will be used as a source. And minus F, that means first TTL. That's the when the packet sending out, the first packet, the TTL to set, the default is 1. Okay, we should first explain how the trace route is worked. The trace route will list all the hops that this packet passing through. Then how it is worked. The work is based on the TTL value. First, the packet going out, the TTL is set to 1. Then, as we know, each router will minus this TTL by 1. Okay, then the TTL on router A will get a result of 0. Then what happened? Because TTL is 0, then router A will drop this packet, right? Then the packet is dropped, then the router A will sending out and sending back to the source an ICMP message. What message? The packet is dropped. The reason is what? The TTL exceeded. Okay, so when this packet is sending back, then the source address, what source address is used? This source address, okay? The ICMP source address, just the first hop, okay? Then the second time, the host A will sending out the TTL equals 2, okay, equals 2. Then router A minus 1, then gets a result of 1, okay? The 1 not exceeded, so sending to the next hop, okay? Then the maybe RTC, okay? The RTC get this packet, okay? Get this packet and then still minus 1, then this value reached 0. Okay, then the RTC will drop this packet and then sending back another ICMP report that this packet is dropped, and then the reason is TTL exceeded, and then the source IP, just the interface sending back this ICMP message. So this interface is the second hop. Okay, so default step by step can list all the hops this packet have passed. Okay, and then minus if means the first packet. Of course, by default, the first packet is 0, so the first hop can list it. If you specify the first as a 2, then first packet sending out RTA will not reach, so there is no first hop, only begin from the second hop. Okay, and then minus n. N means the time to live. That means when trace route, what is the maximum hop to trace? Okay, if you not specify, the default is 30. That means when the packet have passed 30 hops away but not reach the destination, then the trace will be stopped. Okay. Of course, there are many other options. Okay, and name display the host name of the router in each hop. That means because in this trace route, the report back is the IP address of each source. So if you want to know the router's name, you need to do a reverse command name reservation. Okay, and then the P, the port, the packet sending from source to the destination is by UDP, and then the UDP have a port. If you not specify, the default port is this port. Of course, you can specify a port. Okay, and then this is the trace route result. When you trace route and not specify any options, just following the destination IP address, then the first hop, then the second hop, then the third hop. And each hop, the source did not sending only one packet. It's sending by default, sending 3 packets. So there's 3 times. This is a delay from the source to the first hop, and then the delay from source to the second hop, and then the delay from the source to the third hop. Okay, this is the trace route. Okay, and then we go to the end. And in this summary, there are 2 questions. Which 2 ICMP message types are used as part of successful ping? Okay, as we know, the ping uses 2 ICMP messages. One is echo request, another is echo reply. Okay, this is 2 message types. Okay, in the event that the TTL value in the IP header of the datagram reached 0, what happened? Okay, of course, the TTL, the router, each router, when receiving a packet, then doing the forwarding will reduce the TTL value. But when the TTL value reaches 0, the router will drop this packet. Okay, yeah, first drop. Then what happened? The router will create a packet, create an ICMP message to report this packet is dropped. Report to the source. Okay, of course, report to the source. That means in this ICMP message, the destination IP address is the source of the dropped message. Okay, and then the source is what? Source is the router's interface that's sending out this ICMP message. Okay, ICMP message. Okay, for example, there's a packet, this packet. Of course, this packet, there's source IP and then the destination IP. Okay, this packet is dropped. Then the router will generate will create an ICMP message. In this message, the destination IP just the source IP of the dropped message, dropped packet, and the source IP just in the router's interface, which interface sending out this ICMP message. Then this interface IP address will be used. Yes, this is how the router doing with the packet that the TTL value reach 0. And then we go to the end of this chapter. Then thanks for you to join my presentation. Goodbye.